So, dear students, good morning, good afternoon, and good evening. Based on the time zone at present you are staying. You know very well, I am Selvamani Krishnamurthy, who is sitting in front of you. First of all, I welcome all of you for our YouTube channel. This is Machine Learning video lesson number 9. In this lesson, let us study random forest classifications algorithm. Random forest classification algorithm. The previous lesson, we studied decision tree algorithm. In this lesson, let us study random forest classification algorithm. As usual, let me share our screen. I hope my screen is visible to all. Good. See lesson number 9. Topic is supervised learning, random forest classifications. First, let me study what do you mean by random forest, how it works as a classification. Then we will do one practical real-time example. So random forest is an ensemble learning method. Ensemble means group of learning methods. Go. So random forest can be useful for both classification and regression. So classifications also we can use random forest. For regression also we can go for random forest. In this lesson, let us study random forest classifications algorithm. Okay, good. How it works? See, random forest actually creates multiple decision tree. Previous lesson we studied decision tree, same thing. But it creates multiple decision trees during training time and combines that prediction to make more accurate prediction. That means what? Random forest is a collection of multiple decision trees. Each and every decision tree will give one output. Majority of output can be considered as a correct output. This is what random forest algorithm. Okay, see it here. What are the steps involved? We have one data set. That data set has k number of records. Am I right? Good. Out of this k number of records, n number of random records. N number of random, very few records. Randomly we need to select. And randomly we need to select some column from the data set. Randomly we need to select some records. Randomly we need to select some column from the main data set to create L number of random subset. That means what? We need L number of random subset, many subset. Each subset can contain random number of records, random number of column. Is it clear? That is the meaning. So, n random records and m random features are taken from the data set having k number of records to create L random subset. Now we have so many subset, L number of subset. Individual decision trees are constructed for these L number of subset. Assume we are having 3 decision tree, 3 subset. Okay, we need to create 3 decision tree. That is the mean. Each decision tree will generate an output. If you are having 3 decision tree, means 3 output will come. Final output is considered based on majority for classification. What is the majority of output that should be considered a final output for classification? For regression, average of majority, average of the output should be considered for regression. Majority for classification, average for regression. I hope it is clear. But still, if you have some doubt, I will explain it small and practical. Before that, we will see how random forest algorithm differs from decision tree. Speed-wise, decision tree is very fast, random forest is slow. Decision tree means only one decision tree, whereas random forest, many decision tree are created. That is why about flow. Interpretation, decision tree easy to interpret, whereas random forest somewhat complex. Time, decision tree algorithm needs less time to train. Random forest algorithm needs more time. Computation is less, random forest more. Visualization very simple, whereas random forest somewhat complex. Affected by outliers, highly affected. Decision trees highly affected by outliers, whereas random forest is lessly affected by outliers. These are the difference between random forest and decision tree. Now see, we have one data set like this. Okay, let us proceed for random forest classification algorithm. Here, some customer number is there, their credit score is there, their annual income is there, loan amount is there, loan default. Wherever yes is there, they have loan default. They didn't pay the loan properly. Wherever no is there, they properly paid the loan amount. That is loan default, yes, loan default, no. This is the condition. Here, credit score is the annual income, the customer annual income, how much amount loan amount they took or other. To create random forest classification algorithm for the following data, we can consider credit score, annual income, loan amount as input. Three inputs are there. Credit score, annual income, loan amount. Loan default as output. This is the one data set. Out of this data set, we need to create L number of subset. Each subset can have randomly some records, randomly some column. Okay. First, we will see. Let us create three samples, B1, B2, B3. This is one subset. This is another subset. This is third subset. B1 randomly contains record customer 1, customer 3, customer 5. That means what? Customer 1 I selected for subset 1, customer 3 as well as customer 5. Randomly I selected 3 records with the credit score, one column. That means credit score is a column. First customer, third customer, fifth customer is a record. I selected one this. In same way, randomly B2 contains customer 1, customer 2, customer 3 with annual income. This is another column. Randomly B3 is another subset. It randomly contains customer 2, customer 3 with the loan amount. That means what? I have one big data set. Out of this big data set, I created 3 subsets. Each subset contains randomly some record, randomly some features. I hope this is clear. Now, let us check this B1 subset. Customer is there, credit score is there, loan amount is there. For this B1 subset, I need to create one binary, one decision tree. In same way, for B2 subset also, I need to create another decision tree. For B3 subset also, I need to create another decision tree. Since I created 3 subset here, I need to create 3 binary tree. Let me create 3 binary tree here. See, decision tree 1. This decision tree 1 is built on B1 subset. That means what? It has one column input, one column output. That means credit score should be considered as input. Loan default should be considered as output. See how it works. That means here we are having 3 values, 700, 720, 600. For 700, 720, no. For 600, yes. That means what? In between 600 and 700, we can select 650 randomly. Okay. If credit score is less than 650, loan default is yes. If credit score is above 650, loan default is no. This conclusion we can come. See, credit score is a root node. If credit score is less than 650, loan default is yes. If credit score is more than 650, credit score is no. In same way, let us create decision tree for subset B2. Subset B2 input is annual income, output is loan default. 5,000, 6,000, 50,000, 60,000, 48,000. That means we can go for 50,000 as a middle value. If the annual income is less than 50,000 means loan default no. If annual income more than 50,000 means and loan default is yes. We can conclude. In same way, let us create another decision tree for subset B3. For subset B3, loan amount is the input, loan default is the output. For 25,000 it is yes, for 18,000 it is no. That means minimum option, middle value, we can consider 22,000. So if the loan amount is less than 22,000 means loan default is no. If the loan amount is more than 20,000 means loan default is yes. So these are the decision tree we created. For example, now three decision tree we have. One new customer comes with a credit score 670, annual income 62,000, loan amount 26,000. This customer we don't have before. This one once again I repeat the same thing. For a new customer with credit score 670, annual income 62,000, loan amount 26,000. This decision tree one created based on credit score will give no. Why? Because credit score is 670. 670 comes L side, so no. Annual income, that is decision tree 2 build on annual income will give yes. Why? Because annual income is 62,000. It gives yes. Decision tree build on loan amount, that is decision tree 3. It will also gives yes. Why? Because loan amount is 26,000. 20,000 means yes. So three decision tree gives three different value. Decision tree 1 gives no. 2 and 3 gives yes, yes. Which is majority? Yes is majority. That is why since yes is majority, final output is yes. That means loan default, yes. We can conclude like this. So I will explain the same thing in front of you. Then you can easily understand. Before that, I need to upload the CSV file. I have one CSV file, loan details, in my E drive. Let me upload this loan default available under E drive. See it here, this is what CSV file. Here I uploaded, fine. Now I can go for Jupyter Notebook. Yeah. As usual, I need to import pandas first. I need to import pandas first. So I need to create one data frame pd.read underscore csv. My file is available, already uploaded, loan underscore details.csv. So I created one data frame. Let us wait for a few seconds. It's creating. Okay. So I got one data frame with the credit score, annual score, credit score, annual income, and loan amount as a input. Output is loan default. So far, no problem. Good. Now come here. This is what already I created. Now I need to create one random forest classifier model. So this random forest classifier model I need to import from sklan.ensemble. So sklan.ensemble is a one model. From this model, I can import random forest classifier class. So I imported. After that, I created RFC underscore model is a random forest classifier model. Here, I gave n estimator equal to 3. Why? Because I want to create 3 decision tree. Any number of decision tree you can create. Since my model contains 3 input, I prefer n estimator equal to 3. You can create 1 decision tree, 2 decision tree, 3 decision tree, that's up to you. So I prefer 3 decision tree. So now model is created. I need to train the model. So here RFC underscore model is a random forest classifier model. Using fit method, I want to train the method. Three inputs I get: credit score, annual income, loan amount. I get this loan default is a output. So now this random forest classifier model is properly trained with existing data. This data. Now I want to predict new output for a new input. See, RFC underscore model that predict 670 is a credit score, 63,000 is a annual income, 26,000 is a loan amount. It shows yes. That means what? Loan default, yes. Similarly, I give another input, it goes no. Loan default as a no. So this problem, this random forest classifier model correctly predict the output. First, it predict three output for three different decision tree. Out of this majority value, it gives. I hope it is clear to you. Now, let me demonstrate the same thing in front of you. Already I imported one CSV file and created one data frame. Now my aim is I need to create random forest classifier model. For that, I need to import sklan dot ensemble. I create module. From this model, I need to import random forest classifier. Class I need to import. Then I need to create model. RFC model equal to random forest classifier. Within bracket, I need to give n estimator. After I go for three decision tree. Now model is created. I need to train the model. Fit. I have three input. First input is credit score. Second input is annual income. Third input is loan amount. I gave three. Now I need to give output. That is loan default. I hope everything fine. Let me check. See, TS, credit score, annual income, loan amount. Let me check. So now the system is training the model. Let me check if properly trained or not. So it shows some errors, some mistake happened. Let me check. Loan amount. I made mistake. It should be not load amount. It should be loan amount. Again problem. Data frame no attribute. Loan loan. It should be again mistake. It should be loan default, not load default. Loan default. Now it's properly trained with the input and output. Our random forest classifier model is properly trained, ready to predict new value. Let me check. See, new customer came. See, model dot predict. What value we can give? Letter we can give same value 670 credit score, 62,000 annual income. Then we can go for 26,000 loan amount. Let me check what it predicts. So it predicts correctly. Yes. That means a customer with the credit score 670, annual income 62,000, loan amount 26,000 means our system correctly predict yes. This is what we got it. Check once again, we can check here. CTR. So it correctly predicts 6. That means decision tree 1 gives no, decision tree 2 gives yes, decision tree 3 also gives yes. So majority is yes, so output is yes. That is what we get. Better we can give one more value. Let us confirm. That means 750. One more value. 750 is a credit score. 20,000 is the annual income. Then 50,000 is a loan amount. So for them, no. That means a customer with a 750 credit score, 28,000 annual income, 50,000 loan amount means loan default is no. So we give randomly some input. Our system properly predict the correct answer. So today, let me stop here itself. I go. All of you enjoy this lesson. Next lesson, let us study something extra. Until then, thank you, student. Have a nice good day. Bye bye. See you.